Okay, hello everyone. Today let's talk about the second type of modular combinational circuit, encoder. By definition, an encoder is a digital circuit that generates a binary code at its output in response to one or more active input lines. So just from the definition, we can sense that the encoder seems to be the opposite of a decoder. And that is true. And you can also tell this by their names. Decoder, like the input is a binary code, and we kind of figure out this code so we can activate one of the output, right? But the encoder is doing the opposite. So we have an active input. Then based on this input, we create a password or code, whatever you call it, to that active line. Usually it's a binary number. Okay, so they are opposite. And to name an encoder, so usually we call like n-line encoder. N is the number of input. For example, we have a 7-line or 3-bit encoder. Sometimes you will see people talking about how many bits. 3-bit. The number of bits corresponding to the number of outputs. So for the 7-input encoder, we have 3-bit output. Okay. So the truth table for this 7-line encoder looks like this. So at each time we have only one or no input is active, and based on which input is active, we can generate a binary code to represent that state. Okay, so like in this table we can see totally 8 states because we have only 3 outputs, so 8 is the maximum possible state, possible number it can represent. Okay, and it's corresponding to those 8 different input status. All right, but if you look closely, I think quickly you will figure out that there seems some problem with this truth table. And the problem is, what happens if we have, say, we have 2 lines or even more lines are active at the same time? For example, if I have D5, D3, and D7 are 1 at the same time, so what code should I get? It's not showing this truth table actually, right? We have 7 input. So 2 to the power of 7, that's 128. So we should have like 128 different combinations just for the input. By the way, it's also like very hard to design this encoder just by hand by solving the color maps because we have a 7 input color map. It's almost impossible to solve by hand. We have to use computer to do that. Okay. But here, let's focus on this issue here. So how to solve this issue? The answer is to define the priority encoder. So we can assign a different priority level to each input. Most common priority level is that we put the MSB of the input, the highest bit has the highest priority. Priority here means the system or the logic circuit will first look at the MSB to check if it's active or not. Okay, if it's not active, then the circuit will check the next bit. However, if it is active, then it will ignore the other bit. It doesn't matter what the other bit has there, it always generates the code for the highest bit. So if you look at this truth table here, like for those combinations not covered in previous slides, they are all covered here. So X basically means don't care. It doesn't matter what value they are. The system only checks the highest bit that is active. Okay. To give you an example, say, sorry, this should be D7 to D1. So if D7 to D1 are all ones, so I delete this too. So I have 7 ones here. What is the output code in this case? Yeah, I copied from wrong place. So Q0. So what's the value of Q2, Q1, and Q0? Because in this case, the D7 has the highest priority, since D7 is 1. So it doesn't matter what value for D6 to D1, the system always generates the code for D7. And because it's 7, so the code Q2, Q1, Q0 should equal to 1, 1, 1. You got the idea? Okay, now let's look at some special encoders. When we were talking about decoder, we have a special kind of decoder called BCD to decimal decoder. Basically, it converts the input BCD code to a decimal, not really decimal value, but just to activate the corresponding decimal output. Okay, so here we have the opposite. So we have 10 input here, represent the 10 digits in decimal numbers, and at the ending time, if one or more of the input is active, a BCD code will generate it. And by the way, this is a priority encoder, and the higher number here has a higher priority. Okay, but the truth table looks like this. If the first line, the line represents 0 is active, say 1 here, because you can tell both input and output here are active high, right? So if this bit is 1 and the other bit is 0, then we have the code for 0, the BCD 0. Okay. Similarly, if I have the 9 is active, the last 9 here active, it doesn't matter what happened to other input, it always generate code for 9, 1, 0, 0, 1. Simple enough, right? However, in most cases, we don't see that active high encoder in reality. Most time we saw active no encoder instead. The function is similar, but the inputs, both inputs and outputs are active no. So what does that mean? Means if we want to activate one of the input or more of the input, we have to put a 0 on that line. Okay, not 1. 0 means active now. And also when we generate the output BCD code, we also need to convert it. Give you one example. Say this 9, which this 9 representing 8 is 0. The others are 1. Just simple in this case. Okay, so 8 is active, and we normally would think we will generate the BCD code, which is 1, 0, 0, 0. D is MSB. Okay, so this would be the code for 8, but because the output is active no, so actually you need to reverse every bit. So the real code you will see is 0, 1, 1, 1. Okay, basically let's try to do the truth table first here. So this is a D, and then this is DCBA. Here D I mean the input. Maybe I just put the input here. Okay, so if 9, 1 is active, active means 0, the code generated would be the 1's complement of BCD 1. So you will get 1, 1, 1, 0. If it's 2, the opposite of BCD 2. So you get 1, 1, 0, 1. 3, you will get 1100. 4, you will get 1011. 5, you will get 1010. 6, you will get 1001. 7, 1000. 8, you will get 0111. 9, you get 0110. That's what you will get for this circuit. For example, if D9 here to D1 equal to this, what is the output code? So because this is also a priority encoder, since the highest active bit is D9, so the code will be generated for D9, so which is 0110. So you will see 0110 here. Lastly, let's look at a very common application for encoders, and you can see them in the keyboard circuit. So in the graph, you will see this 16 key keyboard here, and you know that this is the kind of the switch turn on and off this keyboard, and it has 16 keys. You got 10 digit key, 10 number keys, 1 dot key, enter, plus, minus, multiply, and division, right? But here let's just focus on the number keys. So we have 10 numbers here, and this is showing how they are wired inside. So we have a resistive and a switch network here. Basically, those switches you see are the buttons, are the key buttons. Okay, they're actually switches. Okay, before we press the key, they are all kind of floating. So they are at the high logic level, which is logic 1. So none of the input in this encoder is active. So the output is all ones initially. So initially the A3 bar, A2 bar, A1 bar, A0 bar is 1111. So nothing is active, and it always generates this code there. However, if one key is pressed, say we press key 0, 0 is using a separate circuit to connect to the internal circuit of the computer to recognize 0. But for key 1 through 9, we use this decimal to BCD encoder. Say if one of the key is pressed, say key 5 is pressed, and there is a circuit like here, will pull down the voltage at this point to ground, like logic low. So it will send a 0 to this input 5 here, and this encoder then will generate the BCD code for 5. If you remember, which is the opposite of 0101. So it should be 1010. And then the computer knows you pressed the key 5 on the keyboard. Okay. For other keys, similar. If we choose a different, say key 9, if we press key 9 on the keyboard, then we have this circuit here to pull down the voltage here to logic low. Then again, this will be 0, and it will generate the code for 9. Got the idea? So now, let's quickly solve this question. What happens if key 1 and key 6 are pressed at the same time? What code will be shown at the output here? As we mentioned before, this is a priority encoder, right? So key 1 to key 6 are pressed at the same time, which means only key 6 will be considered to be active. So the code is actually for 6. For 6, regularly we will get 0, 1, 1, 0, but this is active no. For active no case, we need to flip every bit. So the real code you will get is 1, 0, 0, 1 here. Okay, so encoder is pretty short topic here. Yeah, just like you, if you think this video is helpful, please like, share, and subscribe. See you next time.